Hello friends, welcome back to your favorite channel Science with Mukherjee sir. Myself KK Mukherjee. Today we are going to discuss again another very important thing in haloarenes and haloalkanes. That is, in this video we are going to discuss the elimination reaction or dehydrohalogenation reactions. This is a very important reaction that we are going to discuss. In the previous video we have discussed about many aspects of this, and if you have not observed this video, you must observe it. I am 100% sure that you are going to be benefited out of that content of this video. So let us have today's topic. So today we are going to discuss, that is, beta elimination or dehydrohalogenation reactions. When we heated the alkyl halide in presence of alcoholic KOH, what is going to happen? There is an elimination reaction. The hydrogen from the beta position of the carbon atom, that we can see the beta carbon atom, and halogens, that is from the alpha position of the carbon atom, has been eliminated, and it is going to give a alkene, and this is called the beta elimination reaction, or we can say it is a dehydrohalogenation reaction, because in this reaction both halogen and hydrogen has been eliminated, has been lost from this alkyl halides, and it is resulted in the alkanes. So we write this equation like this way. This is the alpha carbon atom, and the chlorine is attached to this alpha carbon atom, and the carbon atom attached to the alpha carbon atom is called the beta carbon atom, that is beta carbon atom, and the hydrogen is here is beta hydrogen. In presence of alcoholic KOH, and when we heat it, what is going to happen? This hydrogen will be eliminated, and here also the chlorine will be leaved from these alkyl halides, because we know halogen is a very important and very useful living atom. So in this case both the halogen and the hydrogen at the beta position has been eliminated, and it is produced the unsaturated hydrocarbons alkene, and this is called the beta elimination. Why it is beta elimination? Because the hydrogen at the beta position has been lost, and dehydrohalogenation, the halogen at the alpha position has been lost, and these two has been lost, and it giving the minus HCl and giving the your alkane, unsaturated hydrocarbons. So this we see in this compound, that is a primary halide. ethyl chloroethane. This is chloroethane. In the chloroethane, you can see that is a one alpha beta hydrogen atom. But if you see this compound, here also we can see that there is a one beta hydrogen atom, and it will be produced in presence of alcoholic KOH, and it is going to give you a product. It is called propene. That it will give you the propene. Suppose you take another alkene, where you can see that it is having the more than one alpha hydrogen atom. It is 2-chloropropane. 2-chloropropane. Here you can see the chlorine atom in the carbon 2 position, and this also a alpha beta hydrogen. This also the beta hydrogen. So here also we can see the product after the dehalogenation, and the product you will see it is same. So there is no change of the product, because it can, if the hydrogen, beta hydrogen is eliminated from this position and beta hydrogen is eliminated from this position, the product will be same. Now, this is a product. This is 2-bromobutane. Here also you can see this product having the 2 beta hydrogen atoms in this position and in this position, and this is the alpha position. So here you can see the different type of product, and this product is like this. You can see two type of products will be produced, that is CH2 double bond CH3. Here the carbon atom, you have to see whether the carbon atom having the 4 valence or not. See 2, 3, 4, 2, 3, 4, and this product and another product, that is the possibility is there, that is CH2, CH double bond CH2. The question arises from this alkyl halide, that is 2-bromobutane, when it is alcoholic KOH is heated, alcoholic KOH is heated, both the cases, that we will see here, that is the product is butane, but-2-ene. Here you can see this is but-1-ene. Which product will be the forbidden product, and for this you have to see the saytzeff rule. Saytzeff rule, which will be the major product. As per saytzeff, this will be the major product, because as per him, that product will be major product where there is a maximum number of alkyl group present in that product. Maximum number of alkyl group. Here you can see that there is a 2 methyl group present in this alkene. Here you see there is only 1 methyl group present around the carbon-carbon double bond. Here this is the carbon-carbon double bond and the CH3 and CH3. Here carbon-carbon double bond is only this ethyl group is present there. So it is maximum substituted compound. So this product will be the major product as per saytzeff rule. But in chemistry, you can see there is always an exception. There is always an exception, and you can see the exception in case of 2-fluorobutane. In case of 2-fluorobutane, it will follow the Hofmann's rule. Now we are going to discuss the Hofmann rule. Hofmann rule says that hydrogen atom will be eliminated, which will be, here you can see there is a, here one beta hydrogen atom in this carbon. If we say this carbon number 1, carbon number 2, carbon number 3 and 4. As per Hofmann, that carbon atom will be, that hydrogen atom or beta hydrogen atom will be eliminated, which is more acidic. Here, the more acidic hydrogen atom is this. The hydrogen atom is the one carbon atom. Then this carbon atom, because there is CH3 having the very strong inductive effect, I effect, plus I effect in CH3. So, the acidity of this hydrogen atom less. This is higher acidity. So, this higher acidic hydrogen atom will be eliminated, and this product will be this. And this product you can see, that is butane, but 1A. This is but1A, that is the product we are going to produce, and this will be governed by the Hofmann's rule. So now you will understand that for this 2-fluorobutane, for this 2-fluorobutane, it will have this compound, and this is an exception to the saytzeff rule. Now, if we closely analyze this elimination reaction with the substitution reaction, like substitution reaction, we have already understood, we have already studied in our previous videos. There are two types of substitution reactions. Type of elimination reaction are like your SN1, SN2 is E1 and E2. But here one thing that we need to remember, if we go the preference of SN1 reaction, that is ease of substitution reaction and ease of elimination reaction, that will be different in case of E2 reaction. E2 reaction, you see, for SN2 reaction, we know already that order of decreasing the tendency is like this. Primary halide have the highest tendency towards the SN2 reaction, followed by the secondary halide, and then tertiary halide. Okay, then tertiary halides. Whereas in E2, in case of E2, the trend is totally reversed, because tertiary is the highest tendency of this E2 elimination, then secondary, then your primary. So this is how we can see this SN2 and E2. That the trend is totally different. But for U1 and SN1, U1 and SN1, the trend is same. What is the trend? Now first, that is a tertiary. Tertiary we can say 3 degree halide followed by 2 degree halide and followed by 1 degree halide. It is both the cases is the same. Now why it is so, let us understand. And what is the condition for the reaction, because it said substitution. Now we are going to discuss the elimination versus substitution. Elimination reaction versus substitution reaction. What is this elimination reaction? Now in that reaction you can see the hydrogen and the chlorine or bromine. The halogen has been hydrogen and halogen has been eliminated. This is the elimination reaction. Substitution means what? Only halogen has been eliminated and in place of that one nucleophile has been added to this compound, and it will give a new type of compound. So what is elimination reaction and what is that? This picture can make you understand very you can able to understand it very easily. This is a nucleophile. This is a nucleophile. This nucleophile is very higher size, bulky nucleophile. This is the alkyl halide, that hydrogen atom. I am write this hydrogen atom here. This is the hydrogen atom. This is the hydrogen atom, hydrogen atom. What is going to happen? Because of this very bigger size, it would not able to go to this carbon atom. So what will do? It will take up this hydrogen towards itself, and this bond will be fitted there, and this halogen atom will be fitted there, and it will create the elimination reaction. This is basically the elimination reaction what we do. This is elimination reaction. What is going to happen? This will act as a base, and it will take up this hydrogen to itself, and this there will be the bonding. There will be bonding and double bond is created here, and as a matter of fact, halogen atom departs. So it will give you the elimination reaction. But in case of this, you can see now what is going to happen? This can be approachable to this carbon atom. This can attach to the carbon atom, and here the halogen atom will be different, and this will be a substitution reaction. So what is the difference between them? The size of the nucleophile is going to be a criteria factor for the elimination and the substitution reaction. So we can write the first point, the size of the nucleophile higher. The higher size of the nucleophile always promotes the elimination reaction. Higher size of nucleophile. Now it is not a nucleophile, it will act as a base. Here also you can say smaller size of nucleophile always promotes the size of nucleophile smaller size of nucleophile promotes the substitution reaction. That is the first and foremost thing which will going to influence whether the reaction will be elimination or substitution reaction. Second thing that we need to understand, that is it will have the concentration of the solvent. Solvent, in case of solvent, is less polar. That is why we need for the elimination reaction the alcoholic KOH. When we get the alcoholic KOH, then solvent is become non-polar, less polar you can say, right? But here substitution reaction occur with the aqueous KOH. Aqueous KOH means the solvent is highly polar, because if there is a aqueous means there is a lot of H2 is there and it is highly polar. So solvent will be highly polar. And there is a strong nucleophiles. Concentration of nucleophiles will be higher. Here the nucleophile will be, size of the nucleophile will be the higher. Number third, that is the, here the elimination reaction. Elimination reaction is so elimination reaction is always occur in higher temperature. Why higher temperature required for elimination reaction and it is at lower temperature? Why? Why high temperature required? Because in elimination reaction you have to break this bond, you have to also break this bond. Whereas in the substitution reaction you have to break one bond. So this will be have the higher temperature. And that is how you can see the difference between elimination and substitution reaction. There is a specific condition you will need for this substitution reaction and for the elimination reaction. That is all for today's video. If you like this video, you can share to your friends. And I am 100% sure that this will going to give you a lot of knowledge and you can able to understand this is a very important concept in chemistry. Until then, in the next video we will meet with another things, that is the next reaction with the alkyl halides, that the reaction with the metals. Until then, all the best and be best.